Hello and welcome to the lecture on quadratic functions. Remember, a quadratic function from the list of toolkit functions has the form f of x equals x squared. This is the basic function without any shifts, flips, or any other types of transformations, or you can write it as y equals x squared. In other words, the function is quadratic if it has x squared inside of it. The basic graph of a quadratic function looks like this, and it's called a parabola. The parabola starts at the origin, unless it has shifts or any other types of transformations, and it goes through the points 1, 1, 2, 4, and it's reflected with respect to the y-axis, making it an even function. This is your basic parabola. So today we're going to talk more in depth about the quadratic functions and the parabolas. So here are a couple of formulas that we will be working with today. There is such thing that's called the general form of a quadratic function, and it looks like this. This looks very similar to quadratic equations that we have been solving with a, b, and c using the quadratic formula. The only difference is in place of f of x, we would have a 0. So the vertex form of a quadratic function is f of x equals a, which is the exact same a as you saw in the general form. And finally, there is a formula that will help you to find a very specific point on the graph of a quadratic function. That point is called the vertex. That's the turning point of the parabola. So for this basic one, I marked it in red. The vertex is at 0, 0, but it doesn't always have to be at that point in the case when the parabolas are transformed. So the vertex formula is h equals negative b over 2a. This is the formula that allows you to find the x coordinate of the vertex. The second part of the formula, k equals f of h, simply helps you find the y coordinate of the vertex. And all it tells you to do is to take the result from the original formula where you find h and use that number that you find for h and plug it back into the equation of the quadratic function to find k. So for example, if you use the formula and found that h is 2, then to find k, you will replace all of the x's in the given equation of the quadratic function with that 2. So here is a couple of examples. The equations of quadratic functions, the two separate equations, are given to you in vertex form. Remember, it is y equals a, x minus h squared plus k. It's this formula right here, a, x minus h squared plus k. And we are asked to find the vertex. When the equation is given to you in vertex form, it's actually very simple to pull the vertex from that equation. All you have to recognize is where your h and where your k are in that equation. Once you have the h and the k, that is your vertex. So looking at the setup, the h is inside of the parenthesis that follows the x, and the k is in the back. The h has a negative sign inside of the formula. So looking at this number here, the plus 1 in the first example, the h for this specific parabola has to be negative 1. So h is negative 1 simply because for that 1 to become plus 1, it had to have its own negative to communicate with the negative from the formula. The k here is the straightforward sign, negative 2. If you see minus 2k is negative 2. And that's it. You're done. You found the vertex. The vertex is at the point negative 1 comma negative 2. That's your turning point of the parabola. That's where that parabola will start. For the second equation on the right here, for the second example, your h is positive 3. Again, remember, this negative belongs to the formula. So unless the 3 has its own negative, in that case, you would see a plus here. The h is actually a positive 3. And then k is a straightforward sign. It's a 2. So the vertex is at 3, 2. There's a couple of other things you can figure out from just looking at the equation, specifically looking at the a. A is this number here in vertex form. So a here in the left example is negative 2, and a in the second example is 1. The sign of a tells you which way the parabola opens. If a is negative, parabola opens down. And if a is positive, like in my right example, the parabola will open up. In the first case, when it opens down, the parabola is said to have a maximum. And if it opens up, it has a minimum. I'm going to use the same two examples and show how we can easily graph these functions on the coordinate plane. So remember, this was my first example, y equals negative 2x plus 1 squared minus 2, and we already have the vertex at negative 1, negative 2, and we know that this parabola will open down. So to graph this function, I will first place the vertex, which is the point, my turning point, on the coordinate plane. Negative 1, negative 2, it's the point right here. And then all we have to really have in order to complete this graph is an extra point. To find an additional point, I will use a point that is the closest to our vertex on the x-axis. So the vertex is at negative 1, negative 2. So the closest point to this negative 1 on x-axis, which is right here, could be either 0 or a negative 2. I'm going to go ahead and use 0, and I will replace the x with the 0 inside of my equation. Y equals negative 2 times 0 plus 1 squared minus 2. Or negative 2, 1 squared minus 2. Or yet again, negative 2 minus 2, which is a negative 4. So the second point for our parabola is 0. That's the 0 we picked for the x, comma, negative 4. So I'll place that point, 0, negative 4, on our coordinate plane, and then I will connect the two. Now, the parabola is a symmetrical graph. It will be symmetrical with respect to the red dotted line that I have placed on my picture. So what I'll need to do now is to take this point that we just placed on the y-axis and reflect it on the other side of that dotted line. So here is the reflection, and we're done. The dotted line that I have is called the line or the axis of symmetry. It is a vertical line, and if you're asked to write an equation of it, you would just say x equals negative 1. That's the negative 1 that comes from the vertex. It passes through that negative 1 on x-axis. Let's now look and complete the same work for the second example that we already have some information about. This example is y equals 1 for the a, x minus 3 squared plus 2. Here is our second example that we already talked about. The vertex is at 3, 2, and I went ahead and placed the vertex on my coordinate plane. I also drew the line of symmetry through that vertex. The equation of that line of symmetry is x equals 3, because that's the 3 on the x-axis. And all we have left to do is to figure out an additional point so that we can graph the parabola. I'm going to go ahead and use the point 2, since that's the next point over after the vertex. Vertex is at x equals 3, so my next point over is a 2, you are welcome to use a 4, but 2 just seems smaller and easier. So here we go, y equals 1 parentheses 2 minus 3 squared plus 2. So the second point for my parabola is at 2 comma 3. So the 2 is this x that I chose to replace x with, and 3 is this 3 that I got from doing so. So the point 2 comma 3 is located right here, and I'm just going to connect that point with the vertex and then reflect it on the other side of the line of symmetry. So it's right here. Now remember, when I was introducing you to quadratic functions, I gave you two different forms of the quadratic functions. The first one was the vertex form, which we have looked at already. It's right here. And the second one was called the general form, and that is right here. The next couple of examples will be dealing with the general form, y equals ax squared plus bx plus c. So here's an example of a general form of the quadratic function y equals 3x squared plus 6x plus 1. If you compare it with the formula, your 3 here is the a, and 6 here is the b, and 1 here is the c. Those are the same a, b, and c that we use for the quadratic formula to solve quadratic equations. The a is a useful piece of information because it tells us if it will open up or down depending on the sign. Well, a here is a positive 3. That means the parabola will open up and it has a minimum. But we know that for us to graph the parabola, we need to have a vertex. So to find the vertex, we will use the vertex formula. I'm going to go back to my original slide. And this last one here, vertex formula, h equals negative b over 2a, finds us our h, which is the x-coordinate of the vertex. And then we will use the h to put back into the equation to find k. So here we go. We find the vertex by using the formula h equals negative b over 2a. My b is 6, so negative 6 over 2 times my a is 3. That's negative 6 over 6, or negative 1. This is the x-coordinate of the vertex. Now I have to find the y-coordinate of the vertex, which is k. To find k, I will be finding f of negative 1. So I will be replacing every x in my original function here by negative 1. So the vertex is at the point with coordinates negative 1, comma, negative 2. I will go ahead and graph this point. So here is the point with coordinates negative 1, negative 2. Here is your line of symmetry for reflection. The equation of that line of symmetry is x equals negative 1. And now we just need an extra point to plot on our picture. So the vertex on the x-axis is at negative 1, so I will use either a 0 or a negative 2. I will go ahead and use the 0, it's just simpler. My x is 0, here is my y. So f of 0 equals 1, and that is the point right here. The coordinates are 0, 1. And I'm going to connect, and then I will reflect that same point on the other side of the line of symmetry. Here you have your parabola. In the next couple of questions, I will be providing you with the equation of a quadratic function, and I will ask you to find x-intercepts of that quadratic function. So given the equation f of x equals x squared minus 5x minus 24, I'm asking to find x-intercepts. So far, all I know about this equation is that it is a parabola and it will open up because my a is positive 1. That's all I have. Remember that x-intercepts for any function, including the quadratic function, are points where your graph hits the x-axis. So in the case of the parabola, these here would be x-intercepts. And anytime we are talking about the x-intercept, the y is always a 0 because those are the points on the x-axis. So to find x-intercepts of any function, including parabola, we have to make our y a 0. The y is right here. So to find the x-intercepts, I will write 0 in place of f of x. Looking at this is a quadratic equation. So the factors here are x minus 8 and x plus 3. With this, your first x-intercept is at 8, and your second x-intercept is at negative 3. Sometimes you might see x-intercepts referred to as zeros of the function. If the question is asking you to find zeros of the function, the procedure is exactly the same, and you give your answers the same way. I have mine boxed, x equals 8 and x equals negative 3. If the question is asking you for x-intercepts of the function, then oftentimes you will be asked for a point 8, 0, negative 3, 0. Here is another example. Find zeros for the function y equals 6x squared plus 7x plus 1. I will go ahead and replace y with 0. And we can solve this using either factoring or the quadratic formula. For the sake of this example, I will use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying under the radical, we have 49 minus 24 over 12. Square root of 25 will eventually give us a 5. The two answers are either negative 7 plus 5 over 12, which is negative 2 over 12, simplified to negative 1 over 6, or the second answer is negative 7 minus 5 over 12, which is negative 12 over 12, which is negative 1. Those are the zeros of the quadratic function. If you were asked for x-intercepts, you would write these as negative 1 over 6, 0, and negative 1, 0. Lastly, some questions will give you the equation of the quadratic function and ask you to find the y-intercept. Remember, when we were looking for x-intercept, we made our y a 0. Similarly, to find the y-intercept, we will make our x a 0. So to find the y-intercept, we're simply finding f of 0, which is 3 times 0 squared minus 4 times 0 minus 2. And that's a negative 2. The y-intercept is at the point with coordinates 0, negative 2. So here's an example of an application of a quadratic function. Suppose a company has a profit function given as the quadratic equation, P for profit, where Q is the number of thousands of sunglasses produced by that company. How many thousands of pairs of sunglasses will need to be produced to maximize the profit? Now, looking at this quadratic function, we see that A is negative. This means my parabola, once graphed, will open down. So it will look somewhat like that. And that means that the turning point, which is also the vertex, will represent the maximum profit for that company. So when you're asked to maximize or minimize, for that matter, something with the quadratic function, all you have to find is the vertex for that function. So find the h of the vertex. We will use the formula negative b over 2a, and that is negative 6 over 2 times negative 0.01, which is my a, and that gives me 300. So the x coordinate of the vertex is 300. Now we don't deal with x's here. Our x is actually represented by the q, and that is our x-axis. So the h of the vertex is the x, or for this function, q of the vertex. To find the k, we will have to find p of 300. That's the function p, and I will replace in q in this function with the 300 that I just found. The answer here is 862. Here's another example of application. A rocket is launched and the trajectory is given by the quadratic function h of t, where h is the height and t is the time that passed since the launch of that rocket. So I'm going to draw a little picture here. My y-axis is how high the rocket is at any given time with respect to the sea level. So here is your rocket. It's starting at some sort of launching platform, and then it's sent into the ocean, and then eventually it reaches the maximum height, and then it will splash back into the ocean. So the vertical axis again here is the height, h, and the horizontal axis is the time, t. I will not be solving this, but I just wanted to discuss what it is that you're asked to find with each question of this application. The first is find the maximum height. Well, the maximum is, with the parabola when it opens down, is the vertex. So when you're asked for the maximum height, you will find, and actually the time when that height is reached, all you have to find is the vertex, the h and the k. Do not confuse the h from the vertex with the height here. The letter is the same, but they represent different things. The time the rocket will splash back into the ocean, that's this point right here. So the time the rocket will splash back into the ocean is the x-intercept, and that's where you make your y 0. And then finally, the height of the launching platform, that's this point right here. And to find that, you find the y-intercept.